you have any questions on those three? All right. Yeah. 2x squared on which one? The first one? Yes, it should be 2x squared. Thank you. That's why she's in BC, guys. All right, 2x squared. I did not look very carefully, did I? All right, so my guess is we may have questions on 3 for sure and maybe 5. Okay. What does this mean to do? How many times should I write it? Twice, okay? Because it's a FOIL problem, right? It's not you don't distribute the exponent in, because you wouldn't have gotten this, okay? So if that means write it twice, doesn't that mean write it twice? It's the same problem, isn't it? It's just got weird looking roots in it. Sometimes you have to go with the algebra rules you know and just follow the rules and hope for the best, okay? All right, so let's go back to our rules that we know. What's square root of 5 times square root of 5? 5, that's a shortcut, right? All right. Whenever you have something inside a radical times something inside a radical, you multiply them together. So what's square root of 5 times negative square root of 7? It's 5 times 7, guys. 35. So, and there's a negative in front. So negative square root of 35. Okay. All right. Then I've got negative square root of 7 times square root of 5. What's that going to give me? Yeah, same thing. Negative square root of 35. Negative square root of 7 times negative square root of 7 is positive 7, because I've got a negative times a negative goes positive, and the number underneath, it's the same. We just, or multiply by the same thing, you get the number underneath, right? All right, I should do some combining like terms now, right? So what is 5 plus 7? Good. Then what happens is these square root of 35s, they act like variables. So I just add the coefficients in front. They both happen to be negative 1. So it's negative 1 and negative 1. Negative 2, we're not multiplying, we're adding now, right? Negative 2 square root of 35. Okay. All right. Let's take and attempt to, so on this one here, what does instinct kick in and tell you to do? Distribute. When we are multiplying variables, what do we do with the exponents? Add them. So this is x to the negative 1 plus negative 5 plus x to the negative 1 plus negative 3. So what is negative 1 and plus negative 5? Good. And what is negative 1 plus negative 3? Good. Are they happy where they're at? No. What do I need to do? They're upstairs. Where should they go? Downstairs, right? Okay, so 1 over x to the 6th goes positive, 1 over x to the 4th. You can ask the BC students. We use that almost every day, okay? Only we usually move them up instead of down, but we use it all the time, okay? All right, we good on the first 5 now? Hopefully not too bad. All right, we're at 11:07. Oh, we got lots and lots of time. Okay. All right, let's take a look at number 6. So read number 6 to yourself for a minute. Okay, this is function composition. We did it early on in the school year, okay? So we're going to try to kind of refresh our memories. Really, your instructions are back here. What this is saying is they want you to substitute the g function into the f function. So I'm going to take g and plug it into f. The way that I told you how to do this is you write your f function out. So I'm going to write the notation f of g of x. Notation in calculus is really critical. So you need to make sure you're practicing proper notation all the time. Okay. You're going to write out your f function, and instead of writing the x, you write parentheses. All right, now I'm going to substitute the g in. So I'm substituting in x minus 2 for both the parentheses. All right. What does this mean? Write it twice, and then you're going to FOIL, right? Or if you prefer the box, you can do the box. Then distribute the 4. So you need to do the parentheses with the exponent first. Okay, so write it twice, FOIL, then distribute the 4. I'm going to let you finish it. Everybody try to get that one finished. Okay. Your first step, once you've written it twice, is to FOIL that out. Distribute in the middle. Okay, check with your table partner. Have a discussion. Okay. We are going to have to FOIL right here, right? So let's do that foiling. So what was x times x? Good. What'd you end up with in the middle? Good. So I'm combining in my head, right? I've got negative 2x, and negative 2x means negative 4x in the middle. I'm eliminating a step. What's negative 2 times negative 2? 4. What should I do back here if I'm going to keep going on this? Good. Instinct should kick in. Distribute the negatives. So negative 2x, and then what's negative 2 times negative 2? 4. Good. Plus 1. Okay, what do we have to do with this for? Distribute. Good, so we've got 4x squared minus, what's next? Plus 16 minus 2x. Could I put these together now, I guess? I don't have to, I could wait. Doesn't matter, your choice. All right, we're almost there, you ready? So 4x squared, let's see, what's negative 16 and negative 2? Negative 18x, and then 16 and 5. 21. Okay. That's it, right? Okay. It wasn't bad, right? It's been a long time since we've done that. Okay. Really long time since we've done that. We're going to see this structure of this a lot in AP Calc. So we do things a little differently with it, but we're going to see that structure. So it's important that you understand the structure. Okay. All right. The next problem I'm going to tell you, I wrote a bad problem. We're going to work it, but my solution isn't great. So I made probably a boo-boo in there somewhere, but we're going to at least get the idea down. Okay. So read it to yourself. Read number 7 to yourself. Okay. So they give us what f of x is, and then they say, hey, we want f of x to be greater than 0. And then we're supposed to like solve and graph our solution. So couldn't I just take this, since this is f of x, is substituted in there for f of x? That's what I would have done with it reading it. So that's what I'm going to do. X minus 8 times 4x minus 2 is greater than 0. Okay. Let's pretend for a second. Don't do this part, just watch. Let's pretend for a second I didn't have greater than 0 and I said equals 0. What would you tell me to do next to solve it? Zero product property, right? So why couldn't I do the same thing with the inequality sign? So let's do that. So I'm going to go x minus 8 greater than 0 and 4x minus 2 greater than 0. Oh, that was ugly. I was just trying to make it look like a better alligator. All right, what do I need to do with the 8? Add it. Okay, so when I add it over, what do I get? What's 0 plus 8? 8. That was an easy one, right? Okay, on the other one. What am I going to do to move the 2? Add it. Good. What do I do with the 4? Divide. What is that really? 1/2. Good. Give you a few seconds to catch up. Okay. Now, that's technically we've got it solved. But remember when we did less than and greater? Look back at the original. Which one is it? Less than or greater? It's a greater symbol, right? So this should be an or. Technically, we should have the word or in the middle there of our answer. Okay, so technically it would be this. Okay, yeah, you remember, see? You see why I did all the crazy things I did? Because it makes you remember, right? It comes back a lot faster. Now, technically we should graph it. It's a number line graph. I would typically put a 0 on there. I'd put probably a 1, a 1/2, an 8 somewhere down there. I guess you really don't need the 1, but you just need to have the basic markings on there. Should my dots over the top be open or closed? Open. Why? Good. There's no equal to. Excellent. All right. Now, remember there was a secret because we got to draw arrows over the top, right? There's a secret to that. As long as your x is on the left, remember how these things make arrowheads pointing the right direction? So the 8 would point to the right and the 1/2 would point to the right. Typically, we don't see that. That's why I think I may have written a bad problem, but hopefully you see the concept is there, okay? Typically, ors point away from each other and ands point towards each other. So there's something goofy going on that I didn't catch. But I may have tried to also add something in to make this cover like two things instead of one, and I probably should have stuck with one thing, okay? All right, any questions on 7? All right, I want you to read number 8 to yourself. Okay. You guys actually know what to do. It looks a little crazy, doesn't it? Like, how the heck are we supposed to get B and C when all I know are the x-intercepts? Okay. So remember, if we're quadratic, okay, what that means is we've got a parabola and our x-intercepts are here. Okay. Those are also our zeros. They're all the same thing. So what I'm thinking is maybe we could reverse the zero product property. Okay. So I'm going to start there. And I'm going to start trying to get my binomials, because I know that when I have to do my zero product property, I take apart two binomials, right? Let's go back and look at that. We've done that this period, haven't we? Somewhere. We did it up here somewhere, didn't we? Maybe not. Oh, we did it here. We did it like 2 days ago, right? So look at this. I'm starting here, and I'm going to reverse that and go up to try to get the answer, okay? So I'm starting with where I'm equal to. I want to get to a binomial and a binomial. All right. So how do I move the 6 to the other side? Good. So x minus 6 equals 0. How do I move the 3 to the other side? I think I heard add. Okay. So that would be what we get after we split it from zero product property. Let's put it back together. So we've got x minus 6 times x plus 3 equals 0. What do you think we should do there? Yeah, we're going to have to FOIL it. All right, you guys should be able to FOIL. FOIL it and figure out what b is. Okay, check with your partner if I see if you guys have the same b value. All right. Do we agree with what I have when I FOILed it together? -3, -18? Which one's the b? 3. Look at, compare this to this, right? The b is in the middle spot, so it's got to be -3 is the answer for the b. Okay, I know I should not have written that in highlighter yellow, but I did. Okay? It's not that you couldn't do the problem, right? It was the way that they started setting it up, right? You all know how to FOIL. We all know about the zero product property. Just they ask the question really weird, okay? So sometimes you have to kind of work it backwards with what you know. All right, let's take a look at number 9. 9 I know is going to be one of your favorite problems. Read number 9 to yourself. Okay. I'm just going to draw a symbol up there and see what the reaction is here. Do you remember? Yeah, there we go. That's what I was expecting. Long division. Okay. I guess we could do synthetic division on it. No, we can't. It's got a fourth power. We can't do synthetic. So we only can do long. Oh, we know we could. Let's do synthetic. You guys want to do synthetic? Do you remember synthetic? No? Okay, well, let's do long because we'll maybe remember it better. We've done long division in elementary school, so let's go with long. Okay, so whatever we're dividing, the bigger exponent is going to go on the inside, smaller exponent on the outside. Okay? I want you to go back and think about this concept, this x to the fourth, as if we were doing our box, okay? So you got to ask yourself, what times x is going to be x to the fourth? Or how many times is it divided? What do you think? So what would I have to put here? What exponent would I have to put here to be able to get a 4 here when I multiply them together? 3. So this is going to be x cubed. Okay. All right. We're thinking back to the process of long division from elementary school. Okay. How many I'm going to distribute this through. I'm multiplying. So x cubed times x should be x to the what? Fourth. That was the way, that's what we forced it to be. We want that because we want that to cancel. Okay. X cubed times negative 2 would be negative 2x cubed. What's the next process in long division? The next step? We got to subtract, okay? But we had a shortcut last year. What was our shortcut? Instead of subtracting, we did what? Flip what? Yeah, you got to flip the sign. So I'm going to change the sign. So negative, positive. It's the same thing as subtracting, right? We just distributed the subtract negative 1 through, okay? These cancel like we planned. So now I've just got 2x cubed. Well, guess what? I have to get all the way till I can't divide anymore, right? I need to get to a remainder, so I need to do it again. All right, so let's do it again together. How many times does x divide 2x cubed? What do you think? 2x squared. Good. Notice we went down an exponent, right? Down an exponent from what we're trying to divide into. All right, we're going to distribute again. So what's 2x squared times x? 2x cubed, which is what we planned on, right? Because we want it to cancel. 2x squared times negative 2 is? Negative 4x squared. Good. Okay. What's my next step? Change the signs. Okay, so I'm going to switch. I'm going to flip the signs. Actually, I'm going to use a different color to do that. Flip the signs. All right, what's left now? 4x squared. Okay, the process continues. So I want you to see if you can continue the process now until you get to something. We're going to get it down to just a number. Okay, so everybody try it on your own real quick, okay? Okay, check it with your table partner.
Bro, dude is writing when I'm writing. Yeah,
Do we agree with 16? We good? Now, we would have probably, the proper way to write it, we would have said 16 over x minus 2. I believe they're just going to look for the number 16. Okay, so you kind of got to go with what's there. All right. Okay, we've been at this for a really long time. You guys have earned a brain break. Okay, so I want you to go into Google Classroom, go look at the stream in Google Classroom. Okay, I put one of your favorite things right there. Okay, I'll give you a couple minutes to try the puzzle. Okay.
But like, you're not gonna find a better what? Trying to date yourself. Maybe we're to put it too.
Big hint, look at the title of it, right?
Wait, I think that's something. Oh, wait. Oh, I know. Bro. Bro, what is he doing? I didn't bring the comment today. Magic. Oh.
Shh, don't say it out loud. Only do Delta Math right now because I haven't set up the other ones yet.
I wonder what it could be second.
When you get it, you're not supposed to yell it out. We had a rule first period last year, didn't we? Okay. Levi will get really mad at you if you yell out the answers. Okay? All right. He's a pretty big guy. I don't want him mad at anybody. All right. Okay. Let's go back to number 10. We're going to see if we can get 3 more done here, and then I talk to you really quickly about the strategy on the test tomorrow. Okay? All right. So we're looking at number 10. We have some absolute value. See, these are all different, aren't they? Isn't this great? It's like we're reliving all of Algebra 2 in 3 days. Okay. When we talked about this a few minutes ago. Less than or greater? Greater. So we know it's got to be an or. Okay. This one's going to work out better than the last one did. So whenever I have an absolute value, remember I split it into a positive expression and a... Oh, see, remember that one, a negative expression, because I was so obnoxious, right? Positive expression and a negative expression. All right, what am I going to, so I'm going to try to solve that now. Okay, so what am I going to do with the 1? Really, guys? You got positive and negative. What are we going to do with the 1? Subtract it over. Okay, so when I do 10 minus 1, what do we get? 9. Okay, what am I going to do with the 3? Divide. So we get 9 divided by 3 is 3. Good. Okay, what do we need to do with it? What's instinct kick in and tell you to do with this? Distribute. Good. So we've got negative 3x minus 1 greater than or equal to 10. Okay, what are we going to do with that 1 now? Add it. So what is 10 plus 1? 11. Good. What are we going to do with the negative 3? Divide it. What? There's something weird that happens. What happens? We got to flip what sign? The greater than becomes a less than, right? We got to flip the inequality sign. That's just one of our rules. And leave it as a fraction, please. Okay. All right. It was an or, wasn't it? Okay, so I'm gonna try to graph it again. I'm hoping this one turns out. So I'm putting 0 on. I know negative 11 thirds is down here. 3 is up there somewhere. It's an x, right? Is it open or closed this time? Closed. Why is it closed? Yep, there's an equal to. Excellent. Okay, remember x on the left, it makes an arrowhead. So the 3 has got to point to the right. The negative 11 thirds has got to point to the left. And that is what it should have looked like in the other one. Okay. All right, we're going to keep going. We got 2 more I want to talk about. Take like 30 seconds and read that to yourself. Okay, good news is we only have to write an equation. We don't need to solve anything. Okay. What does area mean of a rectangle? What's that? I know you know it. Length times width, right? Okay. And it says the area equals this. So I know that my area is 400 and I got to figure out my length and my width. Okay. It says that the width is x. So I know the width equals x. I'm going to write that a little differently. Width is x. And then it says the length is 2 meters less than width. So I'm going to take the width and what am I going to do? What does less than mean? Subtract. Now I'm just going to multiply the length and the width. So x minus 2 times x. Now, it's entirely possible that's not the equation that they give you for the answer. So let's do a little bit more, okay? What does instinct tell you to do with this? Distribute. So 400 equals x squared minus 2x. The other thing that might happen is they might take this and move it over to the other side. So where it would be like 0 equals x squared minus 2x minus 400. Or could my 0 be on the other side? Does it really matter where I put the 0 equals 0 part? It could look like that. Okay. All right. Last thing I want to review really quick, and then I've got to talk to you about the strategy. Okay. I gave you a crazy graph. Okay. And I know we're going to have to zoom in because I made them, I squished the graphs really good. All that it's asking me to do is they give you h of x, graph each of the following. Okay. This is the move it left, move it right, move it up, move it down thing. Okay. We did a lot of that last year. It doesn't matter what crazy graph they give you. You just have to know how it moves. Okay. So when you come in or out of parentheses, what do we have to do with the sign? Flip it. So this is actually going to be plus 2. So that would be to the right 2. Okay. So I'm just going to take my points. I'm going to go to the right 2, right 2, right 2, right 2, it's about like that. So it's going to be something like this. I probably missed on the last part. I'm going fast. What's going to happen with this one? We've got a positive 2 in parentheses, so what's going to happen?